Welcome back to Dream Recompile. In today's tutorial, we're recreating that cinematic camera stop effect inspired by Devil May Cry Definitive Edition. Let's jump straight in. So, inside your third-person camera boom, you'll find a section called Camera Lag. When you enable it, the camera no longer sticks rigidly to the player. Instead, it follows with a bit of delay. When you're designing something like a Devil May Cry style camera, you'll usually keep a moderate lag speed, around 4 to 6, just enough to give cinematic weight but not too much delay. When you set this to 1, the camera moves very loosely. It feels heavy, like it's floating behind the character, slowly catching up every time you move or stop. Let's move on to adding a bit of impact to our shots using camera shake with Perlin noise. Start by creating a new camera shake blueprint. Right-click Blueprint class, search for Camera Shake Base and select Default Camera Shake Base. Let's name it BP_Camera Shake. When you open it, you'll find the oscillation settings. This is where the fun begins. Here, we can control the camera's pitch, yaw, and roll movement, basically the small vibrations that make your camera feel alive during hits, impacts, or stop effects. If you set your pitch or yaw amplitude to around 10, the shake becomes intense. It's great for explosions or heavy impacts, but a bit too chaotic for cinematic action gameplay. For something more stylish and controlled, like in Devil May Cry, you actually want very subtle values, something like pitch 5, frequency 10 to 15. That creates a tight, punchy vibration that you feel. Now let's trigger this camera shake using AnimNotify, so it syncs perfectly with your animation timing. Place this notify on the exact frame where the impact or stop happens in your animation. Then, in your anim graph as event graph, right-click and add on Notify Begin Camera Shake Notify. From there, use Try Get Pawn Owner to get the player character reference. From that, call Get Player Camera Manager. Finally, trigger Start Camera Shake, and select our BP_Camera Shake class. This way, the shake will always trigger frame accurately with your animation. No delay, no desync. Alright, now let's move on to the final step. This is where we'll add a smooth camera stop and settle effect using a timeline and a few simple float nodes. Create a timeline in your character blueprint named CamPunch. Add a float track that goes from 0 to 1 over about 0.3 or 0.4 seconds. This curve defines how strong the camera offset will be. First, I'm storing my default arm length at begin play. This is important, because we'll always want to reset back to the camera's original distance after our zoom effect finishes. The timeline drives a Lerp linear interpolation node. Here, A is the current camera distance, B is our new zoomed-in distance, and the alpha comes from the timeline output, labeled zoom alpha. That output connects to set target arm length, updating our camera boom in real time. We use two custom events: trigger idle zoom when the player stops moving and reset idle zoom when they start moving again. Next, I'm reading the move input axis value using enhanced input action_move. We convert it into a vector 2D length, so we can check whether the player is moving or standing still. This feeds into a branch node. If the length is greater than 0, that means the player is moving, and if it's 0, the player's idle. This setup might look simple, but combining input checks, timeline lerping, and camera arm updates gives you a really dynamic, responsive feel, especially when you layer it with the camera shake and lag from our previous methods. Here's the before and after. On the left, a static camera that just follows. On the right, our dynamic setup that zooms, shakes, and breathes with the gameplay. That's what gives your camera the same cinematic feel you see in DMC or other stylish action titles. And that's it for today's breakdown, so stay tuned, and as always, thanks for watching, and I'll see you in the next one.